B. If an alternating current I varies sinusoidally, it could be represented by the equation I equals Im sine 2 pi ft, which is equals to Im sine omega t, where I is the instantaneous current at time t, Im is equals to maximum peak or value of current or its amplitude, omega or 2 pi f is equals to the angular frequency of current, f is the frequency, omega t is equals to phase angle, which is the state of periodically varying system at a particular time. Note: the phase difference between the voltage and the current through the RLC series circuit is represented by the equation tan phi equal to x over capital R. Root mean square RMS of AC. The root mean square RMS value of an alternating current is that direct current which produces the same heating effect per second in a given resistor. P equals to I squared R. For an AC circuit, the instantaneous power is given by P equals to IV, instantaneous value. IRMS equals to IO all over square root of 2, which equals to I efficiency, where IO is the maximum steady current. Similarly, VRMS is equals to VO all over square root of 2, which is equals to V efficiency, where RMS is the root mean square and the VO the peak value or the maximum steady voltage. Example 1. When the root mean square voltage of a source of electricity supply is given as 240 volts, calculate the peak value of the supply UME. Solution: V root mean square equals to VO over square root of 2 equals to V efficiency, but V root mean square is equals to 240 volts. 240 is equals to VO over square root of 2. VO is now equal to 240 times square root of 2, which will give us 339.4 volts. Example 2. Calculate the instantaneous value of a current if in a circuit it has root mean square value of 15.0 amp when its phase angle is 30 degrees. Solution: I equals to LO sine W omega t is equals to I root mean square equals to LO over square root of 2. IO is equals to square root of 2 I root mean square. I is equal to square root of 2 I root mean square sine omega t is equals to square root of 2 times 15 sine 30 degrees. I is equals to 7.5 square root of 2 is equals to 7.5 times 1.144, which is equals to 10.6066 ampere or 10.61 ampere approximately. Example 3. In an AC circuit, the peak value of the potential difference is 180 volts. What is the instantaneous PD when it reaches 1 over 8 of a cycle? Solution: 1 cycle covers 360. 1 over 8 cycle covers 360 over 8, which is equals to 45 degrees. Capital E is equals to capital EM sine omega t, which equals to capital EM sine 45, which equals to 180 sine 45, which equals to 180 times 1 over square root of 2, which gives us 90 square root of 2 volts. Reactance: the opposition offered to the passage of an alternating current by either the induction or the calculate or the both is called reluctance. Thus, reluctance X of an inductor L or capacitor C can be defined by the equation reactance S equals to minus amplitude of voltage across L, or C all over amplitude of current through it. S equal to Vm over Im. 1. The reactance for a capacitor is given by Xc equals to Vm over Im, which equals to 1 over 2 pi Fc, where C is the capacitance of a capacitor. Impedance. The overall opposition of mixed circuit to the flow of an alternating current in a resistor and or S equal to Vm over Im. 1. The reactance for a capacitor is given by Xc equals to Vm over Im, which equals to 1 over 2 pi Fc, where C is the capacitance of a capacitor. Impedance. The overall opposition of mixed circuit to the flow of an alternating current in a resistor and or capacitor is known as impedance. Impedance Z is equal to V over I, which is equal to square root of in brackets SL squared plus capital R squared, where L and R are in series, which also equals to V over I, which equals to square root of in bracket S squared C plus R squared in bracket C and R in series, which also equals to V square root of in brackets R squared plus SL plus SL squared, where L R in series. Unit. Resistance R, reactance X, and impedance Z are all in ohms. The frequency F in hertz, the inductance L, and capacitance in farad F. Series circuit. 1. L and R in series. I V squared is equal to V squared L plus V squared R. I is equal to V over Z, which is equal to V over square root of V of X squared L plus R squared. I tan theta is equal to VL over VR, which is equal to ISL over IR, which is equal to XL over R. Figure 435 velocity diagram. 2. Capital C and R in series. I equals to V squared C plus V squared R. I equals to V over Z, which equals to V over square root of in brackets S squared plus R squared. I tan theta equals to VC over VR, which equals to IXL over IR, which equals to XC over R. Figure 436 shows the vector diagram. 3. L, C, and R in series. V squared equals to V R squared plus in bracket VL plus VC squared. I equals to V over Z, which equals to V all over square root of XL plus XC squared plus R squared. I tan theta is equals to BC over OC, which equals to VL minus VC all over VR, which equals to IXL minus IXC over VR, which equals to XL minus XC all over R. Figure 437 shows the diagram of a vector diagram. Note, I in equation 1, I, 2, I, 3, I. The current I lags on the applied voltage V by an angle theta. 2. XL is equal to IXL